Welcome everyone who's joined us. I know we've had a switch over, a change in topics from the first session on vintage computers. Now we're going to turn over to some very interesting, at least I find it very interesting, technology that is being developed by students at the College of New Jersey in the electrical and computer engineering department. And in some cases, there are interdisciplinary presentations here with students from more than one discipline. We're going to begin with our first presentation. These are our students who are working on their senior project, and as part of that project, they're developing basically a hearing aid for pets, particularly focused on dogs, because they have a need for that. And it's using, I won't go into details, but quite unique. The whole team is not here, unfortunately, but we have some key players here. Ta'al Ahmed and Miguel Flores are going to be the presenters, and they were supported by Colton and Chris. So I'm going to let, I guess, Tal, are you going to start off, Tal?
Yes, Dr. Katz.
Okay.
Thank you. Good morning, everyone. As Dr. Katz kindly introduced us, my name is Talal Ahmed. Miguel Flores has also joined us. Unfortunately, our other team members, Chris Cassini and Colin Earhart, couldn't make it. They're currently away. But our project is the hearing aid for dogs. We'll dive right in. So a quick overview of the project. I mean, traditionally, hearing aids for pets cost on average from anywhere from $3,000 to $5,000, which is very costly. We'll go over a little later the budget of our project and how we've tried to keep the cost of the product as minimal as possible. So the product, our finished product, will be something that is cost effective and convenient for the average, buyer, where it's not too expensive for an owner to accommodate for their pets. Typical hearing aid, obviously, is one in which sound signals are amplified. This will be a little different. In this case, our hearing aid is directed towards pets that cannot hear at all. And so the idea will be to utilize vibrations, convert sound signals into vibrations that the dog, or any pet for that matter, will be able to recognize. The idea is to use a microphone which will receive the sound signals, have a microcontroller that will amplify the sound signals, that will send, that will process the signals and send them to the vibration motors that will activate and vary depending on the frequency and amplitude of the sound signals that the microphone receives. And we'll go into that a little later. For us, this project really hit home. There was a true purpose to it because one of our team members, Colton, his brother's dog is actually deaf. And the idea is to create a product that we can use for pets like Jackson, that they can then use to be able to recognize sounds in their surroundings without hurting, without it affecting their safety, no matter where they go. And so, which brings us to the purpose of our project, which is to allow hearing impaired dogs to react and respond to the sounds around them, so that to increase the communication between them and their owners, to promote a dog's safety and their awareness. Now, breaking down the goals of this project is the first to transform signals, sound signals from the surrounding areas into vibrations on a dog's skin, torso, to filter sounds from the microphone to account for the number of vibration motors activated, as well as the frequency of the vibrations by varying the PWM, the pulse width modulation, which we'll go into a little later as well, to mimic binaural hearing, which is the ability to hear with both ears and recognize which direction the sound is coming from, to turn the circuitry into a printed circuit board to make it as concise and light as possible, and to develop a Bluetooth low energy app for manual control of the vibration motors and the device itself, along with a GPS tracking feature. The specifications of our device: it will be a microcontroller based board with 6 PWM output pins for 6 different vibration motors, 3 on the left side, 3 on the right side of the harness of the dog. The power supply will be 3 volts to 5 volt components, with LEDs to indicate the state of the device, whether it's on or off. The microphones will be able to receive frequencies between 20 hertz and 20 kilohertz. The microphone will also be unidirectional, which it will be able to recognize whether it's coming from the left side or the right side. Its battery life will range from anywhere from 7 to 12 hours, depending on how often it's kept on and the time of the day, and how busy the surrounding areas that the pet is in is. The harness, which is adjustable but large enough to fit Jackson for the time being. Eventually, we'll try to produce a device that we can implement on any type of harness of any size, with the entire system, which will be attached to the harness, should be just under a pound. So very light, very convenient for pets. The environment, the operation temperature range will be from anywhere from 0 to 120 degrees Fahrenheit, for basically environments here in Jersey. We don't usually get anything past that range, and it will be waterproof as well in case of rain, snow, etc.
So here you have the hearing aid layout, and the microphone will receive audio from sound, and then the microphone will send the signal to the Arduino, and then the Arduino would perform an FFT to find the frequency, and it'll also show us the sound level, which will then we'll use that information to control the vibrators and see how much it will vibrate and how much vibrators will be active. So for the vibrators, we have the sound level from 45 dB to 60 dB. Only one vibrator will be active, and then from 60 dB to 75 dB, 2 vibrators will be active, and then greater than 75 dB, all the vibrators will be active. And from the short and the right, you can tell how loud something is. From the top, it will be the quietest, to the bottom being the loudest. And it also tells you the frequency of each object in the short. You go to the next slide. So for the vibration motors, so from 0 to 2 kilohertz, it'll be the vibration motors will be active 100%. Like, so it'll be the strongest vibration. And from 2 kilohertz to 6 kilohertz, it'll be 67%. So it'll be 67% strong. As it wouldn't like vibrate as strong as the 0 to 2 kilohertz. And then from 6 kilohertz to 19 kilohertz, it'll be 33% active. And here we have the PCB creation. As you can see, we have this will be our design for the PCB when we make it. I believe we already made it and it's already been shipped to Colton's house, but Colton has it now and we don't have any photo of it, so we're not able to show it. But this is what it should look like. And here we have the harness design. In the leftmost picture, we have the design of the harness. So we have the PCB that's going to be laid out in the middle, connected to the nano. And then the PCB would also be connected to the battery, and it will just connect everything to the harness. So we have the vibrators right there in the left side and the right side. And we also have the microphones where it shows where the microphones will be. And then in the middle picture, it shows a dog wearing it. That's my dog. It's not Colton's dog that actually be using it. But it will just show how the harness should be on the dog. So it's not that different from Colton's dog. And you can see in the bottom right, the dog being comfortable. So you can see how the dog is, the dog could be sleeping while having the harness on. I don't want to be disturbing it. And we also have a prototype, I guess, of the circuit board that's going to be shown. It's going to be created into a PCB, so it should be much smaller.
One of the things that we have been working on is an app for our device. We've been trying to use Android Studio to produce the app. The purpose of the app will be to provide a few different functionalities, one of which will be to able to turn the device on and off upon the owner's discretion. If it feels like, it's there's a lot of noise where you're in a busy city, maybe you don't want it to be on 24/7. If it's, if you're at home, you're not really doing anything, maybe you don't need it on, so you can basically, that will allow the owner to be able to turn it on and off. The owner will be able to vary the intensity of the vibrations as well from the app. And the app will also be able to locate the dog at any moment through GPS technology. So these are the few functionalities that the app will have and will give to the owner. And it's something that we are currently working on. Here's a quick demo of last semester. So just to preface this, the main component we've been missing is our PCB, which now that we have, we'll be able to complete our device, our product, and attach to the harness. And we should have a finished product very soon, now that the PCB is in. But this is a quick demo of what the device will look like when it's fully attached to the harness.
So when the audio gets closer to the microphone, it activates the vibrations, as you can see from here. The louder the noise, the more vibrations gets active. And here we have the spectrum analyzer to show the frequency of what's happening in the surrounding.
And that's pretty much where we're at in terms of the project. Any questions?